So 3-1, we're going to focus on lines and angles. So I'm going to first introduce to you two different types of lines. This came up in last chapter on one of the homework questions. I don't remember if you guys asked this one or not. 2 of my 3 classes did. I don't remember if you were one of those. But there's 2 different types of lines we're going to talk about, okay? Parallel lines. Can you tell me what parallel lines are?
The lines that don't intersect.
Lines that don't intersect, yes. However, that's not a complete definition of parallel lines, because today's lesson, you're going to learn about 2 different types of lines that never intersect. And one is called parallel and one is called skew. So you have to be a little more specific in your definition of them. So parallel lines are going to be coplanar lines. Okay, and that's the key difference right there is coplanar. Coplanar lines that do not intersect. Sorry, I didn't really put a space in there. So parallel lines have to be coplanar. The way that we will mark parallel is we'll just draw 2 parallel lines. So when you see that, you need to think, is parallel to? Okay. And when we mark lines parallel on a figure, so I'm going to draw a cube for you right now. Go ahead and draw one with me if you would like. But I'm just going to show you on this cube how we mark things parallel. Okay, so let's say we have a cube that looks something like this. We're going to call this top face A, B, C, D, and the bottom face E, F, G, and H. I'll give you a second to draw that with me here. Anyone think they can tell me a pair of parallel lines right now? Jason.
A, B, DC.
A, B, and what?
DC.
DC. Okay, so we would say AB. We're going to call this a line because we're going to say those are planes that keep going, okay? So AB, we would say, is parallel to line DC. So line AB is parallel to line DC. Now here's what I need you to see. The way that they're going to show you that they're parallel is they're going to put little arrows on the different lines. So for instance, if I'm looking at AB and DC, they would put an arrow on AB and an arrow on DC. That shows that those are parallel, okay? That way, if we have a different set of parallel lines, we can mark those as well, but a different way. Just like we did with the angles and the segments, right? We just kept adding lines to it. That's how it's going to work with these also. So we could also say that HE is parallel to GF, or FG, doesn't matter the order. And if that's the case, are those parallel to AB and CD? No, those are not parallel to AB and CD. So these ones you would mark with double arrows then, because we don't want to say they're the same as or parallel to the top ones, but we want to say they're parallel to each other. Okay, so double marks on those. So if you had one more set, triple marks. If you had another set after that, quadruple marks, okay? So you just keep increasing your markings. Questions on parallel? Okay, here's the one that is probably new to you, and the one that people always forget about when they say parallel lines are lines that don't intersect. Skew lines, okay, S-K-E-W, skew lines are non-coplanar lines that don't intersect, okay? So this is going to be non-coplanar. Non-coplanar lines that don't intersect. What does non-coplanar mean? Not in the same plane, right? Non-coplanar means they're not in the same plane. So we are looking for 2 lines that don't lie in the same plane and will not intersect. Anyone think they can find skew lines for me?
Like this.
Yeah. There it is. It was this class. You remember. Yes, they're these ones, right? Can you tell me a pair? You got one, Luke?
EH and FG.
EH or D?
DH and FG.
DH and FG. Yes, good job. DH, okay, line DH and line FG are skew. Do you see that? So DH is going this way, FG is going this way. If I show you on a Kleenex box, maybe it is a little more clear. So DH in this picture is a back edge here. FG is a horizontal one this way, okay? Those two lines are never going to touch each other, but they're not parallel because they don't lie in the same plane, okay? Can someone give me a different set of skew lines? Nolan.
Line EF and line CG.
So EF, that's this one here, and CG is that one there. Because one is in front of, well, the horizontal is in front of the other, right? They're not going to hit each other at all. So EF and CG. And then those are just ditto marks, are skew. Okay? Questions on that? All right. Then the other term that you need to know is parallel planes. And you can probably gather what parallel planes are. But if you just look, actually, let's look at this picture up here. Okay, so if we look at our cube, can you tell me two planes that you think would be parallel? Yeah, Chloe.
Plane ABE and DCG.
ABE and DCG, yes. So she's saying the front plane, right? ABE would be this plane here. And then DCG would be the back plane, okay? Those two planes are never going to touch each other. So plane ABE. The letter you could add to that if you wanted would be an F, right? ABEF, that's the, well, ABFE, the front plane. And then you could also say plane, the back plane DCG. And if you wanted your fourth letter there, that would have been the H. Okay, but you can just do it with 3. You don't need all 4 letters. Okay, so let's just do one example with these guys. Let's say we have a rectangular prism. And I'm really just doing exactly what we just did, just all in one problem. So if you don't need to write this down, if you've got it, that's fine. Don't worry about writing it down. I just want to see that you've got it. So. Okay, so let's say this is our picture. Can you tell me a line that is parallel to AB? Okay, we'll call it segment AB. Parallel to AB. Yeah, Carson. DC would be one. Anyone see another one? HG. Any more? EF. You guys are great. Okay, so that's parallel to AB. How about skew to EF? Okay, so here's EF. First of all, pick a line that's actually drawn in, because you could come up with other lines, right? I could say line AH, but that one's not drawn in. So pick ones that are drawn in here. How many skew lines are there in this given picture to EF? Or can you just name one for me? DH would be one. That's this one here, right? That's skew. What else? CG. Did I hear another one? AD and BC. Good. So AD and BC. Any other ones? That's it. Okay, so in a box setup, a cube, a rectangular prism, any prism that has a rectangular base, you're gonna have 4 lines as options that are skew to any one given line, okay? So that would be our 4 for this one. How about, can you tell me a pair of parallel planes? Parallel planes.
A, E, H, and B, F, G.
Yeah, so if we do the front and the back again, AEH and BFG, right? Those would be parallel. So plane AEH and plane, I forget what you said, BFG? Okay, and if you want to add the 4th letter on, that's fine, but you only need 3. Okay. Okay, now can you tell me segments parallel to plane BC, BCGF. Okay, so first think about, where is BCGF? Which plane is that? That's the back plane. Okay, so if this is the plane we're looking at, I want all the segments that are parallel to that. What segments would be parallel to that? What plane was parallel to that? ADH, right? That whole front plane. So that means any segment on that front plane. So AD, DH, HE, and AE would all be parallel. Okay? Any questions? Okay. Then what you're going to see a ton of in this chapter are transversals. And I feel like people are used to the transitive property, and then they see transversal and they get the 2 words mixed up. So think transverse, like across, transverse. Basically a transversal, I'm just going to draw you a picture. We're most of the time going to work with a transversal when there's parallel lines, but the lines don't have to be parallel to have a transversal. Your transversal is just a line that intersects 2 or more coplanar lines. So if I draw a line through this here, okay, this we would call our transversal because it's cutting through the 2 blue lines, all right? So what happens is you end up with all these different angles. Okay, and that's what we're going to be talking about a lot today, is what types of angles are we getting out of this picture. So first thing you need to know is you will have an interior set of angles and an exterior set of angles. So if we think interior here, interior means it's going to fall between the 2 lines that are not the transversal. So interior angles would be all of that. Okay, that's the interior. Does that show up okay? Yeah. But then you also have the exterior, and the exterior would be everything else. So oops, that's not a highlighter. Let's try that again. So this and this are your exterior. That's here and there. Okay. So with that, there are different names that go along with these. God bless you. Your first one is alternate interior angles. Okay, oftentimes if you hear me say AIA, those are alternate interior angles, okay? And here's what you gotta think about. Your name tells you what they are. So alternate interior angles. Anyone have a guess what alternate interior angles might be? You should know right now which ones are your interiors. I want a pair of angles, so two angles that are alternate interior. Jason.
Basically, it's the one on the opposite side where it's 3 with the 6, right?
Right, so it's on opposite sides of your figure. So 3 and 6, right? Those are on opposite sides of the transversal. And they will be inside the other two lines. So alternate interior angles here would be angle 3 and angle 6. Do you see another pair of alternate interiors? 4 and 5, good. Angle 4 and angle 5. And today we're not going to talk about how they relate to each other really, but we will get into that very soon. I just want you to know what they are right now, okay? So that's alternate interiors. Then there's also same side interior, angles. Okay, and I will often call these SSIA. So if you see that abbreviation, and you're welcome to use these abbreviations too, okay? As long as you use the right letters, I'm fine with it. So same side interior angles, what would those be? 3 and 5. And 4 and 6. Good. So they're on the same, here's our transversal, right? They're on the same side. 3 and 5 are both on the left. 4 and 6 are both on the right. Okay, so that's same side interior angles. 2 more. Then we have what are called corresponding angles. Okay, I don't really have a shorthand for this. I'll oftentimes just do this, corresponding angles. For corresponding angles, you have to think, what does the word corresponding mean? It means they relate to each other. They are corresponding. So corresponding angles will sit in the same place in relationship to the vertex. So here's a vertex up here. Here's a vertex down here. If I'm looking at angle 1, for instance, the corresponding angle on the other vertex is which one? Angle 5. So it would be top left with top left of your 4 angles. Do you see that? Okay, so corresponding would be angle 1 and angle 5. Can you give me another pair of correspondings? 2 and 6, angle 2 and angle 6. So that would be top right with top right, okay? 3 and 7, and 4 and 8. Okay, those are corresponding. They sit in corresponding places on the vertex. Okay? Questions on that? Okay. Technically, there could be 2 more sets of angles. The book doesn't really cover the one, but I will just show you. There's alternate exterior. And then the one that the book doesn't cover, so this would be AEA, okay? The one the book doesn't cover is same side exteriors, but they do exist. Same side exteriors would be on the same side of the transversal, but outside, so top way high and way low on our picture here. Can you tell me what alternate exteriors would be in this picture? Alternate exteriors. So if I'm starting, let's start with angle 1, okay? Angle 1 would be an alternate exterior with what other angle, Nolan? That would be angle 8, right? It's on opposite sides of the transversal, but outside of the 2 lines, okay? So angle 1 and angle 8. And then the other one would be angle 2 and angle 7. So then same side exteriors, which I'm not even gonna write down because the book really doesn't cover it. Same side exteriors would be like 1 and 7 or 2 and 8. Those are on the same side of the transversal but outside, okay? Any questions on that? Okay, so I'm just gonna give you a picture and you're gonna tell me what kind of angles you see. Okay, so let's say our picture looks like this. I want to know, do you see a pair of alternate interior angles? Alternate interior. 7 and 4. Is there another one? 2 and 5. If you took notes on this already, you don't have to write this down too, because it's the same thing. I'm just checking that you see them. How about alternate exterior angles? 6 and 8 and 1 and 3. Angle 6 and angle 8, angle 1 and angle 3. Okay. Do you see same side interior angles? So on the same side of the transversal, inside, angle 7 and angle 5. Which other one? 2 and 4. Okay. And then corresponding. Corresponding is always the one that has more. There's just more options available for corresponding. Which ones do you see?
1 and 5.
Angle 1 and angle 5. Angle 6 and angle 4. Oops. 7 and 8. And 2 and 3. Okay. Just keep in mind, corresponding is all about the vertices. So this is top left here with top left here. Okay. Yeah, and we'll go into more of those. I'm going to switch it up a little bit and just see if you still see it. So if this is line L, line M, and line N, which one's your transversal right now? N, okay? So that's the one that you're paying attention to in terms of where things are falling. Okay, so where are alternate interiors? 8 and 6, 4 and 2, okay? Where are the corresponding angles? 1 and 2, right? 1 corresponds to 2, so top left with top left. 8 and 7, 5 and 6, 4 and 3, okay? How about alternate interiors? Did I do that one already? Yeah, alternate exteriors. 5 and 7, 1 and 3, okay? Same side interiors, did I do that one yet? Same side interiors. 8 and 2 and 4 and 6, okay? So your transversal is your reference point. Even if they turn the picture, it's still how are they in relationship to that transversal, okay? Any questions on that? All right.